Hello friends, welcome to CEC Live Lectures. Dear friends, today in this session we are going to continue further with our series on business research methods. Friends, in previous sessions we discussed on various tests. Today we are going to discuss on what correlation is. And to have this vivacious session, we believe that you all are connected with us. Friends, for this session we have with us in our studios Dr. Namita Rajput. Dr. Namita Rajput is a prolific professor. Currently she is Principal in Sri Aurobindo Evening College, University of Delhi. Dr. Rajput is a dynamic professor who believes in giving maximum of her knowledge to the students. Friends, she has authored numerous books. A number of her articles have been published in various journals, various research papers too. If you want to ask questions from Dr. Rajput, then do call us through our toll-free number. Our number is 1800110430. I repeat, our number is 1800110430. Friends, you are requested to call in the last 10 minutes of the lecture. Let's welcome our guest, Dr. Namita Rajput, and let's try to understand what correlation is. Hello ma'am, welcome to the lecture.
Good morning friends. Today we will be talking on correlation. As the concept says that correlation is all about the degree of relationship between the variables under consideration and is a measure through the correlation analysis. In today's lecture I will be covering on the types of correlation, the concept of correlation, the methods of studying correlation, that is basically the scatter diagram, Karl Pearsons rank correlation and method of least square. These are the most famous methods to find out the kind of correlation which is there between the various variables. So taking it forward, I'll start with the concept of correlation. Correlation, as the name suggests, it is the degree of relationship between the variables under consideration and is a measure through the correlation analysis. The measure of correlation is also called as correlation coefficient. So it's a term which is used as a measure for correlation between the various variables under study. The degree of relationship is expressed by a coefficient which ranges from correlation -1 to +1. So this is the highest range, and in between this, the kind of correlation degree, it lies. So it is between +1 and -1. The direction of change is indicated by a sign, that is whether the relationship is positive or whether the relationship is negative. We have to see the particular sign associated with the coefficient of correlation, which is a measure of correlation. The correlation analysis enables us to have an idea about the degree and direction of relationship between the two variables under study. If the answer says the correlation is +1, so we say that there is a positive relationship which is existing between the variables under study, and it is a positive correlation because the sign is plus, and definitely the range under which the correlation lies is +1 to -1. Now correlation is a statistical tool that helps to measure and analyze the degree of relationship between the two variables. The correlation analysis deals with the association between two or more variables. Now, as a matter of fact, there is a confusion always, and people have a concept that correlation and causation are one and the same thing. But yes, this is a myth. We must understand that there is a differentiation between the correlation and causation. Causation means cause and effect relation. Correlation denotes the interdependency among the variables for correlating the two phenomena. It is essential that two phenomena should have the cause and effect relationship, and if such relationship does not exist, then the two phenomena cannot be correlated. If two variables vary in such a way that movement in one are accompanied by movement in the other, these variables are called cause and effect relationship. Causation implies correlation, but correlation does not necessarily imply causation. So this line, a researcher must understand that causation always implies a correlation, but the correlation does not necessarily imply causation. Now, as a matter of fact, we must understand what is the different types of correlation which we are talking about today. Now, there are basically two types of correlation which we are talking about today. One is a positive correlation and the other is a negative correlation. The types of correlation, type 1, positive and negative. So let me give you a conceptual framework of what positive correlation means and what negative correlation means. The correlation is said to be positive correlation if the values of two variables changing with the same direction. For example, the public expenditure and sales, height and weight. So this is a kind of a positive correlation, that is, they are both varying in the same direction. If one is increasing, the other is also increasing. If one is decreasing, the other is also decreasing. So when you talk about the positive correlation, it signifies the same direction. Whether it is a positive or it is a negative is immaterial. But you must understand that there has to be a same directional change between the two variables if a particular correlation has to be called as a positive or a negative correlation. In positive, the direction has to be the same. Whether they are increasing, both of them will increase. If they are decreasing, both of them will decrease. Now coming on to a negative correlation, this signifies an inverse relationship, that is, one variable is coming up and the other variable is coming down. The correlation is said to be negative when the values of the variables change in the opposite direction. For example, as you see in this slide, we have shown here the price and quantity demanded. Now, more or less, people have this kind of a conception in mind that when the product becomes dearer, the quantity demanded decreases and vice versa. So this particular type of relationship, we call it as a negative relationship because the prices are moving up and the quantity demanded is going down. So that means one is moving up and the other is moving down. So this is what is called as an inverse relationship or a negative relationship between the two variables. Now coming on to another aspect of correlation, that is the direction of correlation. The positive relationship and a negative relationship. The variables change in the same direction. As x is increasing, y is increasing. As x is decreasing, y is decreasing. For example, as the height increases, so does the weight. So this is a positive. So it is indicated by a plus sign or a minus sign, but yes, you have to understand this. Both the variables under study, they move in the same direction. Now coming on to a negative direction relationship, the variables change in opposite direction. As x is increasing, y is decreasing. As x is decreasing, y is increasing. For example, as TV time increases, grade decreases. Now we would be coming on with more examples to make you understand what is a positive relationship and what is a negative relationship, so that you have a conceptual clarity in this regard. The positive relationship, we say that water consumption and temperature, the time study and the grades, like the more time you spend on studies, the better grades you get. The negative relationship is that the alcohol consumption and driving ability, the price and quantity demanded. So these examples are giving you a very clear-cut indication of the conceptual aspects of the positive as well as the negative correlation. Now coming on to the type 2 types of correlation, we have already done the type 1. In type 1 we did 2, the positive and the negative. Now we are coming on to type 2 types of correlation. So correlation here I would be talking on the two aspects, a simple correlation and a multiple correlation. In multiple correlation we have again two, a partial and a total. So we would be discussing them one by one to give you the basic insights of what simple correlation means, what multiple correlation means, and when you talk about the multiple correlation, what are the various types of partial as well as the total correlation under study. Now first we would be explaining you what is a simple correlation. Under simple correlation, the problem is of only two variables under study. That is, we take into consideration only the two aspects, only the two variables. Whereas, if you see the concept of a multiple correlation, there are more than two or more than three variables under study. For example, if you see this equation of quantity demanded, it is a function of price, price of other commodities, then price of substitutes, the time and the income aspects. So that means when you talk about the quantity demanded and the relationship of its with the other factors, that means the quantity demanded changes is not only a factor of the price change, it is for the other commodities also, it is for the substitutes also, it is for a time factor also, and it is for the income also. There could be many other factors also associated with the quantity demanded and the changes. Now, this was the multiple correlation. That means there are so many variables under study, that is more than 2 and more than 3 variables under study. Now, when you talk about the multiple correlation, it is again of 2 types, the partial and the total. In partial analysis, it recognizes more than 2 but considers only 2, keeping the other constant. For example, I am trying to find out the relationship of quantity demanded with price and income. So, if you are trying to find out the quantity demanded and the income would be constant. If you are trying to find out the quantity demanded with the income, the prices would be constant. So, there is an assumption in this regard that you are taking into consideration more than 3 variables, but for the concept of calculation, only the 2 variables will be under study, 1 will be kept as constant. So, if this is the scenario, we call it as a partial correlation. Now, coming on to a total correlation is based on all relevant variables, which is normally not feasible. Now, coming on to type 3 of the correlation. Now, type 3 correlation is of 2 types, the linear as well as a non-linear. As the name suggests, the linearity and non-linearity will define the types of correlation. So, let us expand on this. The linear correlation. The correlation is said to be linear when the amount of change in one variable tends to bear a constant ratio to the other change in the other. The graph of the variables having a linear relationship will form a straight line. X is equal to 1, 2, 3, 4, 5, 6, 7, 8, whereas Y is equal to 7, 9, 5, 7, 9, 11, 13, 15, 17 and 19. So, Y is equal to 3 plus 2x. So, that means they are in a linear relationship, and the relationship, if you plot on a graph, it gives you a clear straight line. The non-linear relationship, correlinear. So, non-linear correlation signifies that if the amount of change in one variable does not bear a constant ratio to the amount of change in the other variable, we are calling is at non-linear correlation, and if you plot it on a graph, you will not get a straight line. Now, let us do the methods of studying correlation. We have so many famous methods to understand and study the correlation, and they are so familiar, simple, easy to calculate, and if the researcher has a deep knowledge of any of these methods, you will be able to find out which is the best method of studying the correlation, and how would you find out that the relationship of the variables under study are correlated or not. So, under this we have a scatter diagram, we have a graphic method, we have a Karl Pearsons coefficient of correlation, we have methods of least squares. So, these are the 4 pertinent methods under study, and we will be taking them as one by one. So, starting with the first method, that is a scatter diagram method. The scatter diagram method is a graphical method to calculate the coefficient of correlation. The scatter diagram is a graph of observed plotted points, with each point represents the value of x and y as a coordinate. It portrays the relationship between these 2 variables graphically. Now, see this diagram very carefully. On the x-axis we have the height of A and height of B, whereas on the left hand side on the y-axis we have the weight of A and weight of B. So, if you see the weight and height of A, they are moving in same direction. Similarly, the height of B and weight of B, they are also moving in the same direction. So, if this is the case, that is the quantum of change in one gives you a same quantum change in the other, we call it as a linear relationship. So, this is a perfect example of a perfect positive correlation, as both the variables are moving up in the same direction. Now, let us have another example of the scatter diagram. See this figure. This shows a high degree of positive correlation. If you see the dotted lines of height and weight, both are moving in the upward direction, that is, it shows the positive direction, and of course they show a combination which is moving in the same direction, that is upward direction. So R is equal to plus 0.80. This is the example of a high degree of positive correlation when both the variables are moving in the same direction. Now let us see another example. This is the degree of correlation. This is a moderate positive correlation. The shoe size and weight, both are moving again in the upward direction, but if you see the dotted lines, they are little scattered. So R is equal to plus 0.4. It shows a positive correlation, but it is a moderate positive correlation as the degree of association between the two variables is little less, but they are moving in the same direction. So we call it as a positive correlation, but since the dotted diagram, if you have seen on the screen, they are little scattered. So the scatterness show a moderate relationship, whereas if you see and compare it with a positive correlation, see this graph on the screen, the dotted lines are very close to each other. So this shows a positive relationship, and R here is equal to plus 0.80. Just see the graph here on the screens. The weight and the height is shown on the screen, and if you see the dots available on the screen, they are little scattered, but if you see again on this moderate positive correlation diagram, they are even more scattered. So see this diagram and now see this diagram. Here it is more closely associated with each other, whereas in this case it is a little scattered. So this is a differentiation between a positive relationship of a high degree of positive correlation, and this is a moderate positive correlation because the lines and the dots are scattered from the point of the origin, and R is equal to plus 0.4. Now this is the third type which is on your screen. This is also called as a degree of correlation. This is a perfect negative correlation. R is equal to minus 1.0. If you see on the left hand side, that is the y-axis, this is the TV watching per week, and on the x-axis we have an exam score which clearly states that if you spend more time watching the TV, the scores of the exams which you will get will be less. So that means there is a perfect negative correlation between your hours spent on the TV watching and the hours spent for your studies. That is, your exam scores would go down. So this shows a negative correlation. If you increase on TV watching, the exam scores would decrease. Now this is a moderate negative correlation. Again, if you see the dotted lines here, they are little scattered, but they are in the opposite direction, that is the TV watching per week and the exam scores here. This is a moderate negative correlation, and R is equal to minus 0.80, which shows a negative relationship, but if you see the previous diagram, they are on the one line, so we call it as a perfect. And here if you see the dots, they are scattered on each side of the line, so we call it as a moderate negative correlation, and R is equal to minus 0.80. Now let us see this. This is a degree of correlation with a very weak negative correlation. On the x-axis we have the weight, on the y-axis we have the shoe size. R is equal to minus 0.2. So there are 2-3 things which you have to keep in mind here, that the sign is very important here. Sign is minus only when one variable is going up and the other variable is going down. So that means there is a weak negative correlation in terms of your shoe size and your weight. That means even if your weight increases, the shoe size will not change. So, or maybe it changes, but in a very lesser level or a very lesser degree. Now see, this is a example of a degree of correlation, whereas you have a horizontal line and the half of the dots are above the line and half of the dots are below the line. R is equal to 0.0 in this case. On the y-axis we have the IQ, and on the x-axis we have the height. So which states what? That even if your height increases, it has nothing to do with your IQ levels. Intellectual quotient is not anyways associated with the height. Even if you are very small, your height is not good, but yes, you can be more intelligent with more IQ levels. So that means here there is no correlation as we are getting a horizontal line. If you put the figures on a graph, the plotted diagram which is there on the screen, the points are so scattered that you are not able to find any kind of association between the IQ levels and the height. So R in this case is 0.0. Now see this diagram very carefully. On the left hand side, if you see the green diagram, we have a plus 0.80. If you see the yellow diagram, we have R is equal to plus 0.60. That means both of them are rising. If you see the orange diagram, R is equal to 0.40, and if you see the magenta diagram, R is equal to plus 20. So these are the varying degrees of correlation. If you see here, when the diagram is upright, you have more association. If the diagram goes on a tilt aspects, if you see the yellow, if you see the mustard, and if you see the pink or a magenta, the tilt goes on increasing and the circle goes on increasing. That means the scattered points are increasing. So the more squeezed these points are, the more positivity in terms of correlation is found. So see this diagram again. If you see a moderate correlation, that is 0.80, the figure is more compressed. The figure goes on enlarging if the degree of association between the two variables goes on decreasing. So if you see the last one, that is the pink or the magenta one, the R is equal to plus 0.20, which shows that the points are scattered so much that you are not able to find out the right association, and the R goes on decreasing. So the more squeezed and condensed diagram shows a higher correlation, and the more scattered and the bigger diagram shows less correlation between the variables of X and Y. Now coming on to another aspect, that is the direction of relationship. This is also very important because this is associated and indicated by minus or plus sign. If you see a positive relationship, variables change in the same way. As X increases, Y also increases. As X decreases, the Y also decreases. For example, as the height increases, so does the weight. The negative relationship, the variables change in the opposite direction, that is X is increasing, Y is decreasing. As X is decreasing, Y is also increasing. For example, a TV time increases, the grade decreases. Now, we have done in detail the advantages of a scatter diagram, which is one of the best measures, a very simple method of calculating the coefficient of correlation just by watching the graphs and their directions. So what are the advantages of a scatter diagram? Number one, it is non-mathematical. Any Tom, Dick and Harry, after looking at the diagrams, can conclude whether the association increases or decreasing, or whether we have a moderate, positive or a perfect correlation between the variables or not. Secondly, it is not influenced by the size of extreme items also, because they are plotted on a graph, and the graph shows a particular the association of the two variables X and Y. The first step is investing the relationship between the two variables. So this is the advantage of the diagram. Now we would be doing the disadvantages of a scatter diagram. It cannot be adopted an exact degree of correlation, because it just either gives you the magnitude and the extent, that is, it gives you the direction and it gives you the the overall idea of whether the two variables are associated or not, but it will not give you an exact degree of correlation. So I hope with these words you will be able to find out the best way of finding out, non-mathematical way of finding out the best method, that the scatter diagram is not mathematical, it is not influenced by the extreme items, and of course the relationship would come to you, but not the exact degree of the correlation in this regard. So it cannot be adopted to an exact degree of coefficient of correlation. So this was the disadvantage.
With this note, thank you, ma'am. Thank you so very much for explaining us in detail what correlation is, and we understood the various aspects of correlation. Friends, we would be continuing further and would be discussing more on correlation. We are back after a short break, so be with us. Hello friends, welcome back to this session where we are discussing on correlation. In previous session, we discussed in detail what correlation is and understood the various aspects too. In this session, we are going to study the various other methods of studying correlation, and for this discussion, we have with us in our studios Dr. Namita Rajput. Friends, if you want to ask questions from Dr. Rajput, then do call us through our toll-free number. Our number is 1-800-110-430. Now, I would like to request Dr. Rajput to continue further and explain us the other methods which helps in studying correlation. Over to you, ma'am.
We were discussing the methods of studying correlation, and in the last session I started and completed the first method, that is the scatter diagram. The scatter diagram is a non-mathematical and a graphical method. Just by watching on the degrees and the direction of the changing degrees of x and y, you have a fair idea of whether the correlation exists between them or not. And of course, the plotting of the diagram, plotting of the combinations of x and y will give you a fair idea of whether we have a positive perfect relationship, a positive negative relationship, or a moderate relationship. And for that matter, when the horizontal line is there, there exists no correlation between the x and y. Like for example, if you are increasing on your height, so it has nothing to do with your IQ levels. I gave you this example in the last session. So taking it forward, now we have the other mathematical formulas and the methods to find out the degree of coefficient of correlation, because the most of the problematic aspect about the scatter diagram was that you are not able to find out the exact degree of the correlation. So with this note, we are going to start with the Karl Pearsons coefficient of correlation. This is the world famous method to find out the coefficient of correlation. This Pearsons method is denoted by R, is the most common correlation coefficient. The Karl Pearsons coefficient of correlation denoted by R. The coefficient of correlation R measures the degree of linear relationship between the two variables x and y. So this is the most simple and efficient method and the mathematical way of finding out the coefficient of correlation, which is propounded by Karl Pearsons, and it's denoted by R. The Karl Pearsons coefficient of correlation is denoted by R. It also varies from +1 to -1. The degree of correlation is expressed by a value of coefficient. Direction of change is indicated by a sign, that is -VE, that is negative, and +VE, that is positive. If you see on the screen, the Karl Pearsons coefficient of correlation, when deviations taken from the actual mean, that is R, x and y, it is equal to sigma xy divided by square root of xy into sigma y square. The deviation taken from the assumed mean, R is equal to n sigma dx dy minus sigma dx into sigma dy divided by under root of n sigma dx square minus sigma dx whole square multiplied by under root of n sigma dy square minus sigma dy whole square. Now this is the procedure which every researcher must keep in mind to find out the method of coefficient of correlation. First, calculate the mean of the two series x and y, calculate the deviations x and y in two series from their respective means. So the first method, the first step in calculating the procedure for computation of coefficient of correlation is that you have to first find out the mean of the series, the mean of x series and the mean of y series. So this is the first step, and mean calculation is very simple. Second is you have to find out the deviations of x and y from their respective means, that is x minus x bar. The third is that you have to square each deviation of x and y, then obtain the sum of squared deviations, that is sigma x square into sigma y square. Multiply each deviation under x with each deviation under y and obtain the product of x and y. Then obtain the sum of the product of x, y, that is sigma xy. Substitute the value in the formula. Now we have to find out the interpretation of the correlation of coefficient, that is small r. The value of coefficient of correlation R ranges from -1 to +1. If R is +1, then correlation between the two variables is said to be perfect and positive. If R is equal to -1, then the correlation between the two variables is said to be perfect and negative. If R is equal to 0, then there exists no correlation between the variables. So you have to be very particular about the interpretation part of the correlation. If it is straight +1, it shows perfect positive relationship. If it is -1, it's a perfect negative. If R is 0, that means there is no association between the x and y variables. That is, there is no coefficient of correlation between the two variables x and y. So these are the three extreme steps: R +1, R -1, and R equal to 0. Now coming on to the properties of correlation coefficient. The correlation coefficient lies between -1 and +1 symbolically. -1 less than equal to R is greater than equal to 1. These are the two extremes of coefficient of correlation. The correlation coefficient is independent of change of origin and scale. The coefficient of correlation is a geometric mean of two regression coefficients. R is equal to √ bxy into byx. The one regression coefficient is positive, other regression coefficient is negative. Now there are certain assumptions which every researcher has to understand before you even calculate the coefficient of correlation. First, there is a linear relationship between two variables. That is, when the two variables are plotted on a scatter diagram, a straight line will be formed by the points. The second is cause and effect relation exists between different forces operating on the item of two variable increases. So the first assumption of Karl Pearsons coefficient of correlation is that there is a linear relationship between the two variables when two variables are plotted on the scatter diagram x and y, and a straight line is formed by the points. Number 2, the cause and effect relationship exists between the different forces obtaining on an item of the two variable series. Now, as we have plus, we have the minus of the coefficient of correlation, which is being calculated by the Karl Pearsons method. The advantages of a Karl Pearsons coefficient method is that it summarizes in one value the degree and direction of correlation also. The limitation of Pearsons coefficient. First, it always assumes a linear relationship. Number 2, interpreting the value of R is difficult. Third, value of coefficient of correlation is affected by the extreme values. And number 4, it is a very time consuming method. So if you see the limitation aspects of the Karl Pearsons method, there are so many limitations associated with the Karl Pearsons method. But yes, the main positive aspect of the Karl Pearsons method is that you are able to find out the exact coefficient of correlation between the two variables x and y. So the most important limitation of the Karl Pearsons method of coefficient of correlation is that there is no other assumption except linearity, which is not in real life possible. They always assume that the relationship which exists between x and y is perfectly positive linear relationship, which is in some cases not possible. So this is the biggest limitation. Secondly, it is very difficult to interpret the value of R. And thirdly, when you talk about the extreme values which is there in the series, in the scatter diagram it is not being affected by the extreme values, whereas if you talk about the Karl Pearsons method, if the series has a extreme value, they are extremely affected by the extreme values which is present in the series. It disturbs the relationship, it disturbs the calculations and other aspects also. And of course, when you talk about the calculation aspect of it, it is a very difficult method in terms of calculations, and it is also a time consuming method. Because if you see the steps once again, when you talk about the procedure for computation, let us have a look on the screen again. The first thing which you have to do is you have to calculate the mean of the series of x and y. Then you have to find out the deviations of x and y series using that mean. Then you have to square the deviations, and then you have to find out and multiply deviations with each y and x, and you have to find out the sigma xy, etc. Then you have to substitute in the formula, which is a very difficult formula for that matter. And of course, the major advantage is that you have only one value which shows the degree and the direction of correlation. This was the biggest advantage of Karl Pearsons method. But yes, we discussed the limitation aspect of it, that it is affected by the extreme values. It is a time consuming method, it's a difficult method, it's a mathematical formula, it is difficult to interpret, and it always assumes a linearity in the relationship of x and y. Now we are coming on to a concept of coefficient of determination. The convenient way of interpreting the value of correlation coefficient is to square the coefficient of correlation, which is also called as coefficient of determination. The coefficient of correlation is denoted by r, and if you square it, we call it as r square. The r square is also called as coefficient of determination. The coefficient of determination is equal to r square. Suppose r is 0.9. The coefficient of determination would be 0.9 into 0.9, that is 0.81. So this would mean that 81% of the variation in the dependent variable has been explained by the dependent variable. So this is the most important aspect to be discussed, that if you compare the measures of correlation, the coefficient of correlation and coefficient of determination, the coefficient of determination is much better measure of the coefficient of this aspects of the correlation, because it gives you the square of r, which explains the deviation in the the deviations in the dependent variable, which has been explained by the independent variable also. The maximum value of r square is 1, because it is the possible to explain all the variations in y, but it is not possible to explain more than all of it. So coefficient of determination is equal to explained variation upon total variation. Now coming on to the example of coefficient of determination. R is equal to 0.60, R is equal to 0.30. It does not mean that the first correlation is twice as strong as the second R. It can be understood by computation of value of R square. When R is equal to 0.6, R square is 0.36. When R is equal to 0.30, the R square would be equal to 0.09. So this is 1 and 2. This implies that in first case 36% of the total variation is explained, whereas in the second case only the 9% of the total variation is explained by this. So this interpretation demands again a very important aspects. The explanation says that the coefficient of determination, which is equal to r square, it is equal to explained variation upon the total variation, which gives you that what percentage of the changes in the dependent variable is explained by the independent variable, which is a very, very important thing and interpretation to be taken care of. Now we are coming on to a third method of the coefficient of correlation measure. This is also called as Spearman's rank coefficient of correlation. This is the third method of the measure of coefficient of correlation. When the statistical series in which the variables under study are not capable of quantitative measurement but can be explained in a serial order, in such situation, Pearson correlation coefficient cannot be used, such as a Spearman rank correlation can be used. R is equal to 1 minus brackets open 6 sigma d square upon n square minus n. R is equal to rank correlation coefficient, D is the difference rank between the paired items of the two series, and n is the number of observations. So this explains the concept of Spearman rank correlation of coefficient of correlation. When you have the statistical series in which you are not able to do any kind of a quantitative measurement, in that case the Spearman's rank correlation is used. Why? Because you cannot measure it in the quantitative terms, but you can rank it. So the formula would be R is equal to 1 brackets open 1 minus 6 sigma d square n square minus n is divided by n multiplied by n square minus 1. R is the rank correlation coefficient, D is the difference of rank paired items in two series, and n is the total number of observations. Now we are coming on to the interpretation part of the rank correlation coefficient, that is R, capital R. The value of rank correlation R ranges from -1 to +1. If R is equal to +1, then there is a complete agreement in the order of ranks and the ranks are in the same direction. If R is equal to -1, then there is a complete agreement in the order of ranks and the ranks are in the opposite direction. If R is equal to 0, then there is no correlation. So if you see the measurement aspect of the interpretation of the rank Spearman correlation, it also shows that when R is equal to +1, it shows the positive relationship because all the ranks are in the same direction. If R is equal to -1, it also shows the negative correlationship because they are in the opposite directions, and if R is equal to 0, that means there is no correlation between the combinations of X and Y. Now coming on to a rank correlation R, there are certain problems when the actual ranks are given. Calculate the difference D of the two ranks, that is R1 minus R2. Square the difference and calculate the sum of differences, that is sigma D square. Third is substitute the values obtained in the formula. Now they are when you talk about the rank correlation coefficient, there are certain problems associated with this. If the ranks are not given, then we need to assign the ranks to the data series. The lowest value in the series can be assigned rank 1, or the highest value in the series can be assigned rank 1. We need to follow the same scheme of the ranking for the other series also. Then calculate the rank correlation coefficient in the similar way as we do when the ranks are given. So here you have to be very particular about your own nomenclature, because one can be given to the lowest and one can be given to the highest. But whatever selection you do, you have to follow in the other series also, because one can be for the lowest and one can be for the highest. Now coming on to the rank correlation coefficient, when the equal ranks or ties in ranks are there, like if you have 4 people and 4 of them are ranked as 4, so what to do? So there are so many ifs and buts, and there are so many issues pertaining to this that you have to follow a particular method to resolve in case you have a tie in the ranks. In such cases, the average ranks should be assigned to each, that is individual. R is equal to 1 minus 6 sigma D square plus AF upon n square minus 1. AF is equal to 1 upon 2 m1 cube minus m1 plus 1 upon 2 m square 3 minus m2 plus 1 upon 12 m square 3 minus m2. The number of times an item is repeated. So m, if you see in the formula, if the rank is repeated 3 times, the m would be 3. If m is repeated 5 times, the m would be 5. If m is repeated 6 times, the m would be 6. So then the formula of the average ranking would be increased to 6 times. As is there here in this example, we have 3 times the rank is repeated. So we have AF is equal to 1 upon 12 m1 cube minus m1 plus 1 upon 12 brackets open m2 3 minus m2 plus 1 upon 12 m2 3 minus m2. So m is the number of times an item is repeated. Now coming on to the merits of the Karl Pearsons, Spearman's rank correlation. The Spearman rank correlation is used when we are not able to quantify the rank, so we just rank the variables. This is the simpler method to understand and easy to apply compared to the Karl Pearsons method, because here you just have to do a ranking. But the problem is when the ranks are repeated, and the problem is when you have to follow a same method. Like for example, in the last slide we explained that if you give the rank as 1, so either it should be for the highest or it should be for the lowest. So the hierarchy which you follow has to be in the same order for the other series also. And then if you have the ranks are repeated, or some of the issues are like this, then you have to take care of the average ranking formula, in which the expansion formula was given to you, and which the average ranks would be given to the rest of the aspects and the rest of the series, and we denoted as m. M is the number of times the ranks are repeated. This method is also used when the initial data is in the form of the ranks. So this is a very important and a good method. But every method which has the advantages or has also the limitations aspect of it. So let us do now the limitations of the Spearman rank correlation. It cannot be used for finding out the correlation in a grouped frequency distribution when you are given a range. So this is a complete inapplicable method in this regard. Then we have this method should be applied when n exceeds 30. So when the n is less than 30, again this method is not suitable. So we have discussed here the two limitation aspect of the Spearman correlation. Number one, that it cannot be used for a grouped frequency table where the range is given, and secondly, if the n is less than 30, this method is also not suitable for this method to be used. Now overall, what are the advantages of a correlation? It shows the strength of the relationship present in the variables. It can be used for making predictions of the variables under study. It can be used in many places, including the natural settings, libraries, etc. Then easier to collect the correlational data. So overall, we have studied today in this lecture, we did the various types of methods to form and measure the correlation. The first method which we did today was a scatter diagram. The scatter diagram is a diagram in which the degrees of relationship are plotted on a graph. It's a non-mathematical formula because it's a graphical formula, but just by having the plot of the the concepts of x and y, we will be able to find out whether the association of correlation exists between the variables or not. So either we have a positive correlationship or we have a negative correlationship. The positive correlationship exists when the variables are moving in the same direction, that either both of them are increasing or both of them are decreasing. But in case of a negative correlationship, we have about one variable going in one direction and the other variable going in the other direction. So we have an inverse relationship when you talk about the negative correlationship aspect of it. The scatter diagram advantages is that this is non-mathematical, graphical, easy to use, and of course if it has the data has the extreme values, it is not affected by it. But yes, the most important disadvantage of a scatter diagram is that you will not be able to find out the exact degree of the correlation. Then we have the other method which we discussed today was a Karl Pearsons method. The Karl Pearsons method is the frequently lovable best method to calculate the coefficient of correlation across the globe. It is denoted by small r, and it has a particular formula to be implemented and put into the series, and of course there is a procedure to follow. The range of the coefficient of correlation ranges from +1 to -1, and of course we have a direction also which is denoted by the signs. Now just have a look on the screen. This is the formula for Karl Pearsons coefficient of correlation. When the actual means deviations are taken from the actual mean, r is equal to n sigma dx dy minus sigma dx upon dy divided by under root of sigma n sigma dx square minus sigma dx whole square multiplied by under root of n sigma dy square minus bracket open sigma dy whole square. So d here means deviations. This is the procedure which is in front of the screen. First you have to calculate the mean of the series, then you have to calculate the deviations from the mean of the series x and y, and you have to square it, and then you have to apply that formula to interpret the results of the coefficient of correlation. Now interpretation of coefficient of correlation is denoted by small r, ranges from +1 to -1. If r is equal to +1, it shows a positive perfect relationship. If r is equal to -1, it shows a perfect negative relationship. If r is equal to 0, it establishes no correlation between the series of x and y. Coming on to the properties of coefficient of correlation, because this is perhaps the most important method and needs a recap. The first is the coefficient of correlation lies between +1 and -1 symbolically. -1 less than equal to r is greater than equal to 1. So this is a complete range of coefficient of correlation in which the the aspects lies, and it is perfectly independent of change of origin and scale, and the coefficient of correlation is the geometric mean of two regression coefficients, that is R is equal to square root of bxy into byx. One regression coefficient is positive and the other regression coefficient is negative. Coming on to the assumptions part, there is only one aspect you have to keep in mind, that there is always existing a linear relationship between the two variables x and y. They are plotted on a graph which will be formed by the points. The cause and effect relation exists between the different forces operating on the item of two series. One of the biggest advantage of the Karl Pearsons coefficient of correlation is that under one particular figure you will be able to find out the degree and the direction of the coefficient of correlation. But the limitation part of it is that it is always following a linear assumption, which is not possible in the real life. The interpretation of the value of R is also very difficult, and of course it is very time consuming method because you have to undergo so many calculations, and the calculation aspect is difficult also because you have to first tediously found the mean, then deviations, then square, and then you have to put it in a formula. Then we came out with the concept of coefficient of determination, which is the square of R, and it is a better measure compared to coefficient of correlation simple R. If you multiply R into R, we have a coefficient of determination which shows the ratio of explained variance upon the total variance. The coefficient of determination is a better measure in terms of because it's a very convenient way of interpreting the value of coefficient of correlation is to use the square of the coefficient of correlation, which is called as a coefficient of determination, that is R into R. We have coefficient of determination which is equal to and denoted by R square. Suppose we have R as 0.9, so R square would be 0.9 into 0.9, that is 0.81, which explains variation in the dependent variable because of the independent variable. So that means 81% of the the explained variance is because of that total variance. So this is again a good measure. The coefficient of determination is equal to explained variation upon the total variation. So then we came out with the last concept called Spearman's rank coefficient of correlation. This is used when you are unable to quantify the data and you just have the ranking aspects with you. So you just have to rank, putting a formula of is equal to R is equal to 1 minus 6 sigma d square and q minus n. And then of course there are problems and issues when the ranks are repeated. Then you have to find out the m, that is the number of times the ranks are repeated. You have to modify the formula, you have to explain how many times the ranks are repeated, then you have to put them under the average ranking aspects of it. So here also you have to find out the differences of the two ranks, and then you have to take the square of those deviations, and then you have to apply a formula. But the problem is when the ranks are repeated and equal ranks, or you have a tie in the ranks, so again you have to modify the formula. But the merit aspect of the Spearman correlation is that it is simple to calculate, and of course when you are having qualitative data, this is the best method. The limitation is that the sample size, if it is less than 30, you cannot apply. Then followed by, if you have the grouped frequency table, that is a grouped frequency distribution table in front of you, you cannot apply the Spearman's rank correlation. So I hope with this session you will be able to find out the various measures of finding out the coefficient of correlation and the coefficient of determination. Thank you so much.
With this note, thank you ma'am, thank you so very much for giving us a productive session once again. Dear friends, we would be meeting again soon and would be continuing further. Till then, take care, goodbye. Thank you ma'am, thank you once again.